All right, welcome back, everybody, and to another edition of Tech Transfer Insights for the week. I spent some time editing down the list of universities that we've been using, and I'm hoping that I can get the AI to do the right thing because I already tried this a couple of times and it's been having issues by still selecting things that I have already removed from the list. So we're going to ask it to please select three random entries from this list. I'm going to copy and paste the ones we haven't used yet. Let's see what it comes up with. University of Hawaii, University of Memphis, and University of North Texas. All right, let's start getting to work on that then. I will see you in a second with some technology from the University of Hawaii. All right, so here's a fun one from the University of Hawaii. I think I mentioned before that I am an electrical engineer by training. I've spent most of my career working on PCBs or printed circuit boards. So I've designed them, I've built them, I've tested them, I've repaired them, all sorts of things over the course of my almost 20-year career now. And I figured that someone had a technology like this somewhere. I just didn't know where. So this is the underlying idea behind this is Zog method, which sounds like some sort of alien from a sci-fi movie. I think it actually is. Isn't Commander Zog the bad guy in Toy Story? Zurg? I don't know, something like that. In any case, the printed circuit, this is basically a way of printing, actually 3D printing printed circuit boards. So it seems like they need a substrate. Just looking through this technology, basically there's a micro, I don't know if this is a microcontroller or some sort of timer. I just could have looked up what that chip was, but these are all probably passives, so diodes or resistors or capacitors or something. Basically, they printed the what we call traces. So the metal parts of this printed circuit board have all been actually 3D printed on this circuit board itself. I don't think they printed the substrate. That's a whole other way of thinking of it. But normally, to their point, normally what you do with a printed circuit board is they uh, etch it. So they drill away things and then they use things like masks and photolithography to create uh, traces and pads, is what we call the other thing. So basically, a way of having it's lead free, but it's solder underneath some of these passives and underneath the pads of these circuits. Basically, this is a way of tailoring that, but also you can apparently, and I didn't think of this, but you can make a microelectrical mechanical system in the trace itself by making it hollow. They also said somewhere in here that you can do you can see a single layer circuit board, but you can do multi-layer, which is really important for circuit design. A lot of times, uh, you can, so that's the figure two. Okay, you can do um, 4-layer circuit boards or up to 8. Right? I mean, you can even do more than that if you can fit if it's large enough. But basically, they got a patent for this. So you can make a MEMS system. You can use different filaments with more conductive or less conductive. You can make it flexible, which is another big thing that a lot of people are working on. You can make optical fibers incorporated into it, which is pretty cool. But it does seem like you need the substrate to not be 3D printed. So I think they're just doing the printing of uh, the stuff itself, and also it's a little unclear as to how, like, do you put this through a solder wave machine where you then melt the solder and put all the parts on it? Like, it's still a little bit unclear as to how some of this stuff would work, but I knew someone somewhere had made a 3D printable circuit. So apparently the University of Hawaii has a patent on it. And I can definitely see that being advantageous, making optoelectronics, making MEMS, making it just safer and easier to use in general than the typical way. I wonder where this goes. These don't seem to be vias, but maybe they are. I don't know. Interesting. In general, interesting technology. Tons of applications if you can get it to work right. I'd be interested to learn how much they can do with this 3D printing technology. And whether this is Harhas, that's another thing, is that you're not supposed to put lead in solder anymore. And one of the reasons that lead was so prevalent in solder is because it has a much better melting like characteristics. So I'd be kind of curious what they use as their metal filament. But for now, that is the one from the University of Hawaii, basically a way of 3D printing circuits onto a substrate. So the next one we will go take a look at, if I remember correctly, was it the University of North Texas? We'll do University of North Texas next, then I'll remind myself what the third one is. So, all right, I'll see you in a couple of minutes with technology from the University of North Texas. All right, so I gotta say, this is why I love doing this, because these are things that I literally never think about, and it's an inspiration every week when I get to see what some people come up with. So, this one's from the University of North Texas, and it is basically a way of causing a chemical to be dispersed into wood. So the most common thing that I would think of when you're thinking of this is how you get treated lumber. Basically, anytime you put wood outside or in the ground or anything like that, you want it to be treated, which in itself is a relatively nasty chemical process that requires a lot of heat and a lot of nastiness. This is a solution to that. So it causes a much more natural um, process for it. Like you still get the same sort of chemical response that you would from the typical heat treating or the typical treating process, but it seems like a much more low energy, low hazard way of doing so. But there's more to it than that. So one of the things that I thought was interesting uh, is you wind up with things like you can make wood magnetic or fluorescent or conductive or make it transparent, like, or not have lignin or make it more dense. Like, it's not just the idea of making it treated. It's you can do any of these things. You can make it fire retardant and termite retardant, preservative, which is the standard thing that you would do with, but you can make different kinds of crazy wood using this technique, and that is what sounds so interesting to me. Um, I would love to see fluorescent wood used in building construction or conductive wood used in building construction. Like, that just sounds crazy to me. I'm not sure they've proved this yet, but at least in theory, I could see how that would work. And that just sounds nuts to me. Like this is one of my favorite ones that we've done so far because like making fluorescent wood, never thought that that would be. I mean, I guess in theory I understand that it's possible. I never really understood how, but it definitely could be. Making magnetic wood, right? Could just embed iron nanoparticles in it. Okay. Again, never thought of that being a thing, but sounds pretty awesome, I gotta say. Gigantic market, 152 billion estimated. Not that great of a compound annual growth rate, but still. Global fire retardant wood is actually relatively uh, inexpensive, but you know, that's a pretty impressive number in general. They have a patent for it, provisional patent anyway, back from 2022. But I thought this one was pretty impressive. They didn't say who is the inventor on this, but I'm sure if you looked up the patent, it would tell you. But in general, love this idea. If this works the way that they expect it to, I think this would be a extraordinarily interesting technology and a platform technology at that. So, good job, inventors at the University of North Texas, for coming up with a way of permeating wood uh, via like a process that is seemingly better than anything else that is currently out there, including not pressure treated. It's a big thing. Okay. Next one up, and now that I remember it, is the University of Memphis. So I'll be back in a minute with the technology from them. All right, so here's a fun one to end out the week. I thought this was pretty cool, actually. Um, so in my past life, I played a variety of musical instruments, including one of the first ones I ever did was play clarinet. So I have specifically played a single reed instrument for a number of years. I always really liked it. I still have my old clarinet. It's sitting in another room in the house somewhere. But this one was interesting because it is very specific, but I think very easy to understand if you've ever used a single reed instrument. So this is apparently called the eclipse ligature, which is basically a design of the thing that holds a reed to a single reed instrument. So like a saxophone, clarinet, not an oboe. Um, but it sounds like there's basically an improved sound quality uh, when you use this ligature when compared to a traditional one. At least the, you know, you get some sort of, uh, what do you call it, testimonial from a guy at Indiana who is a professor of clarinet, uh, who's not associated with the University of Memphis, right? And this guy, who is the inventor, is also a professor of clarinet at the University of Memphis. Uh, and, you know, really interesting idea, very simple idea. Again, very simple product. Theoretically would improve upon existing designs. Granted, they don't have a video showing the difference between what a normal ligature sounds like and what this design of one would sound like. But I thought it was interesting. And again, very simple product. They have a patent, is what it sounded like. If I remember correctly, I think I saw somewhere that they did. So the eclipse ligature is the last one we'll be taking a look at this week from the University of Memphis. At least ostensibly improves the quality of single reed instrument sounds, which there's a huge market for that if that is actually true. Um, but I thought it was a fun one because it's very simple to understand, very easy to implement, and probably very easy to manufacture. Like it looks basically just like you need some relatively fancy machining to make this thing, but that's a physical product already. Like, so it's obviously someone has made it at least. And it's obviously been tested by somebody outside of the University of Memphis. So you're already down the path of customer validation at that point. So interesting idea. Uh, thought it was the only downside of it is I think the patent was issued in like 2009, so it's only got about another 5, 6 years of being patented. But in general, I thought it was a really interesting idea. Uh, so think that's it for this week. I'm going to thank the inventors at the University of Memphis, University of North Texas, and I completely forgot what the third one was already. Goes to show you how long I take in between recording some of these. Uh, but, great technologies, really interesting ideas here this week. Oh, well, University of Hawaii, that was the other one, which has probably the coolest track of any university I've ever seen. I ran on it once and it was pretty awesome, rainbow color. So, University of Hawaii, University of North Texas, and University of Memphis all had great technologies. It was very interesting to research each of them. If you guys have any comments about how I could do this differently or better, or suggestions or anything else, very much appreciate it. I will leave links in the description to each of the three technologies that I took a look at today. And if you guys have any comments, suggestions, thoughts, or anything else, please feel free to leave a comment or like and subscribe. And I'll see you guys next week with three new technologies from three new universities. So enjoy your week, and I will talk to you later.